Beneath these mountains, Switzerland built a railway the world once thought impossible.
The Alps are beautiful, but for trans they were a wall.
Older routes climbed the mountain, wasting time, energy, and carrying capacity. Europe needed a faster, cleaner way to move freight through the Alps. Instead of climbing over the Alps, engineers would cut through their base. A base tunnel stays low, turning a mountain crossing into a flatter railway. The finished tunnel would run about 57 kilometers beneath Switzerland.
It was built as twin single-track tubes, connected by emergency passages.
Before digging began, the mountain had to be studied for decades.
The greatest unknown was not distance, it was the rock. Every core sample was a warning from deep inside the Alps.
The mountain was not solid stone. It was fractured, layered, and alive with pressure.
Water inside fractured rock could turn progress into a crisis.
At points, more than 2 kilometers of mountain pressed above them.
Deep underground, heat became another mountain to overcome.
Fresh air had to reach a construction site buried inside a mountain.
To finish in one lifetime, crews attacked the route from multiple fronts. At Erstfeld, the northern entrance began turning drawings into stone and steel.
From Bodio, another front pushed north beneath the Alps. At Sedrun, workers descended into the mountain to create another battlefield.
The tunnel became a hidden city of machines, air, water, and workers. The tunnel boring machines were not drills, they were moving factories. At the front, steel discs crushed alpine rock into fragments. Behind the machine, a river of broken mountain moved outward. Millions of tons of rock had to leave the mountain.
Some of the mountain returned as concrete, lining, and support.
Every new meter needed support before the mountain could shift. At depth, the rock did not just sit there, it pushed back.
Sensors watched the rock for movements too small for human eyes. 2 tunnels advancing through darkness had to meet almost perfectly.
The path underground began with measurements made under open sky. Across 57 kilometers, tiny errors could become enormous mistakes. Progress came meter by meter, repeated thousands of times.
Behind every machine were workers adapting to heat, noise, and darkness.
In a tunnel this deep, safety had to be engineered into every routine.
The same mountain demanded different methods in different places.
Where machines were unsuitable, crews drilled carefully into the tunnel face.
Controlled blasts opened sections the boring machines could not easily conquer.
After every blast, the mountain had to be cleared, checked, and secured.
In weak zones, speed mattered less than keeping the mountain stable. Water was not defeated. It was collected, redirected, and managed.
Eventually, rough stone became a precise concrete railway corridor.
Cross passages linked the twin tubes, giving safety a physical path.
A tunnel this long must plan for problems before they happen.
Above ground, operators monitor the tunnel like a living machine.
Excavation made space. Rail systems made it a tunnel for trains. High-speed trains require tracks placed with extraordinary precision. Electric power turned the tunnel into an artery for modern rail.
In darkness, invisible signals keep every train separated and moving.
Communication systems made the buried railway visible to the outside world.
Even after construction, air had to be controlled with precision.
Every safety system was designed for rare moments, when seconds matter.
Before passengers arrived, the tunnel had to prove every system worked.
The first speed runs transformed years of concrete into motion.
After years underground, the final checks were almost ceremonial.
In 2016, the hidden route through the Alps opened. For passengers, the impossible feels almost ordinary. The flatter route lets trains move faster beneath the mountains. For Switzerland, freight was never a side story. The goal was simple: move more cargo by rail, not road.
In the Alps, infrastructure decisions become environmental decisions.
This tunnel is one link in a much larger European corridor.
Ports, factories, and cities all depend on routes like this.
The hidden railway was built for capacity, not spectacle alone.
Twin tubes help separate traffic and simplify emergency planning. A tunnel this complex is never truly finished.
Engineers still watch the tunnel because mountains continue to move.
Modern tunnels are physical structures connected to streams of data.
Every train enters a schedule measured in seconds and kilometers. Minutes later, the train emerges into a different side of Switzerland. The mountain route still exists, but the main crossing moved underground. By flattening the route, engineers compressed the Alps in time.
Steep grades demand power. Flatter routes reward efficiency.
For heavy freight, a flatter tunnel changes what rail can carry.
Infrastructure like this quietly shapes the economy around it.
This was not just engineering. It was a national decision.
The price was enormous, but the bet was measured in generations.
For 17 years, the project advanced mostly out of sight. Some workers spent a significant part of their lives beneath this mountain. Then came the moment every survey calculation had been waiting for. Only a wall of rock separated years of work from proof. When the wall fell, the mountain finally became a passage. The breakthrough proved the measurements had held across impossible distance.
But breaking through was not the same as finishing.
Now the raw tunnel had to become a working railway. Every system had to work as one 57-kilometer machine.
Then the extraordinary became part of the timetable.
The greatest engineering often disappears into ordinary life.
A portal is the only visible sign of the world beneath.
Most of this achievement remains invisible by design.
The tunnel did not defeat the Alps. It learned their limits.
Patience, precision, and public commitment made the impossible practical.
The future of transport may depend on hidden projects like this.
Building it was historic. Keeping it reliable is the next mission. Inside the tunnel, human ambition feels both powerful and small.
Each passing train carries decades of planning through the dark.
The journey ends in daylight, but the achievement remains underground.
The Gotthard proves geography can be reshaped without forgetting its power.
Even a mountain can become a passage when patience meets precision.